Polynomial long division. Suppose we want to divide 2x squared plus 9x plus 10 by x plus 2. I'm going to use a process that you might remember from doing long division, maybe in elementary school, where I will rewrite my problem in this fashion. And then I want to see how to get this into this. Now, when I'm doing a problem like this, I really only look at the highest powers of what I have left over. I'll explain what I mean by leftover in a bit. But I will look at the highest power in my factor and the highest power up here in my numerator that I originally had. And I could say, what times x equals 2x squared? Well, that answer is 2x. Another way to do it is saying 2x squared over x equals what? Either way, we get the same answer, that I need a 2x right here. So to get this first thing, I only look at the highest powers. But once I get that, I need to multiply that 2x by everything over here, by both the x and the plus 2. So I can go back and do 2x times x, which is 2x squared, and then 2x plus 2, which is plus 4x. And if you recall from long division just with numbers, we would now need to subtract that. And we're going to subtract this term from the term right above it. Since there is a constant term of 10 up here, I'll put a constant term of 0 down there and subtract. If we do this correctly, this first term should always cancel out, and it does. And then I can do the rest. I get 9x minus positive 4x, which gives me 5x. I get 10 minus 0, which gives me 10. So I can do the process again, because x plus 2 can go into 5x plus 10. Once again, I think highest powers only, the x, and now the 5x, the highest power, what's left over. And say x times what equals 5x? Well, plus 5. Or I could have done it the other way, like I did on the right, where I do 5x divided by x equals what? And I get positive 5. So to get this number up top, highest powers only, but then I need to multiply that number right there by the entire factor and put it down here. So I get 5 times x, 5x, plus 5 times 2, 10. Nothing else left over here. We're all good. And don't forget, we need to subtract the entire thing. And we get 0. So what that means is 2x squared plus 9x plus 10 divided by x plus 2 equals 2x plus 5 with a remainder of 0. We'll see soon enough that remainder means that x plus 2 is a perfect factor of 2x squared plus 9x plus 10. In fact, if I multiply both sides by x plus 2, we get the original polynomial in factored form. Let's take a look at another example. Consider the polynomial 2x cubed plus 13x squared plus 17x minus 12. And we want to divide this by, let's say, 2x minus 1. I will rewrite my problem so that I can do my polynomial long division. I'll put 2x minus 1 over here, and then inside I'll get 2x cubed plus 13x squared plus 17x minus 12. And I look at the highest powers over here and the highest power of what's left over to see what goes in my first position right there. So I will do it this way. Highest powers only, 2x cubed over 2x, gives me exactly x squared. So I can put an x squared right there. So to get that first thing, we look highest powers only. But now I'm going to take that term and multiply it by everything over here in my divisor. So x squared times 2x gives me 2x cubed. X squared times negative 1 gives me negative x squared. Don't forget we need to subtract this. In fact, let me get rid of that parentheses right there, because I have terms right above it. And in this line here, I'm going to put down plus 0x plus 0. So to kind of match all my terms together. And when I subtract, those should cancel. They do. Great. I get 13x squared minus negative x squared gives me positive 14x squared. And then I can drop down these next two. Let's continue on. Highest power over here. Highest power, what's left over. That's going to go right up here in my next position. So I will do highest power with its coefficient, of course, 14x squared, divided by the highest power of my divisor, 2x, and that leaves me with positive 7x. So I can put plus 7x. Highest powers only gives me that, but now I multiply that term by both things over here, giving me 14x squared. Great, I should have that. Then negative 1 times 7x minus 7x. And then no constant term, so I'll put plus 0, and I'll subtract it. When I do that, cancel. I did it right. 17x minus negative 7x gives me 24x. And then minus 12. I can keep going. Highest power of what's left over. Highest power in my original term gives me positive 12, so I can put down plus 12 right there. I now multiply the plus 12 by both terms over here and get 24x minus 12. Subtract it off, and we get a remainder of 0, meaning 2x minus 1 is a perfect factor of the original polynomial. And in fact, I could keep going. I could say the polynomial is 2x minus 1 times x squared plus 7x plus 12. But notice that the leftover quadratic is also factorable. So instead of doing long division, I will simply factor it to get to my final factored form. Take a look at one more example where maybe it doesn't work out so nicely. Let's just start like this. Let's do x plus 1 into 3x cubed plus 6x, I left that space on purpose, minus 2. So you might have seen it like this. They say 3x cubed plus 6x minus 2 divided by x plus 1. I left space because when we're doing these problems, I need every single power. And if there's no x squared term, I still have to put a placeholder of 0x squared. So now let's do the long division. Highest power, what's left over, divided by the highest power there, gives me 3x cubed over x, or 3x squared. And that's my first term right there. Multiply that term by both of these terms over here now. We get 3x cubed plus 3x squared, and I'll put plus 0x plus 0. and then subtract everything. That term cancels, as I expect. 0x squared minus 3x squared gives me negative 3x squared. 6x minus 0x gives me 6x. And then negative 2 minus 0 gives me negative 2. Repeat. Highest power here divided by the highest power there. Negative 3x squared over x gives me negative 3x. So I'll put negative 3x right there. Multiply this term by both terms over here. Gives me negative 3x squared minus 3x, and put a placeholder constant of 0. Let's subtract that out. Negative 3x squared minus negative 3x squared, gone. 6x minus negative 3x gives me 9x. Negative 2 minus 0 gives me negative 2. One more time, highest power, what's left over? Divide by highest power of original. It's positive 9, so I'll put plus 9. Multiply this by both terms over here. Gives me 9x plus 9. Subtract it off. Gives me a remainder of negative 11. That's perfectly fine. I could write it like this, minus 11 over x plus 1. Sometimes I write it like that. What does this mean? It means that x plus 1 is not a factor of my original polynomial, 3x cubed plus 6x minus 2.